guys, welcome. This is your test review for Wednesday. I'm going to go over the practice test, not all of it, but some questions. If you watched my last video, you'll know that I went through a lot of similar questions that you'll see on your test. I went on your practice test, so we'll kind of do the same thing today. All right, so let's start. I would say review this page and this page because that's the first thing we did, but a lot of you have forgotten a lot of that by now because we've been busy with electron configuration and orbitals. So go ahead and review that. That is going to be on your test, parts of this, and I'm going to go over those parts right now. Okay, so in the very beginning, we talked about a wave. Okay, and a wave has essentially a few parts, right? The parts that y'all want to concern yourselves with is really the wavelength, which is the distance from, let's call this the starting point to the next starting point to the repetition. So this is a wavelength. Here to there would be the next wavelength because, right, it's from peak to peak. And then you have the frequency. So a frequency is how often this wave is happening. So if this is, let's say this is 0 seconds, this is 1 second. Between 0 and 1 seconds, it took 3 waves occurred, right? Versus you could have had a faster wave, right? And you would have had a lot more waves occur within 0 to 1 second. So this would be an example of a low frequency, and this one would be an example of a high frequency. Okay, now something that you might see on the test is, and it might be asking about direct and indirect proportions. Okay, so remember, direct proportion means if one is high, the other one is high. If one is low, the other one is low. Versus indirect proportion means if one is high, the other one is going to be low, so they'll be opposites. So for example, here, let's look at frequency and then let's look at wavelength. All right, here we have sort of a long wavelength, so we know that that number will be big. And the frequency is slow, so it's not very frequent. So we know that our frequency will be low, right? If one is high and one is low, this is an example of an inverse proportion. It's the opposite. Because this one makes it big, that means this one is small. Let's look at another case. If this one has now the short wavelength, so now the wavelengths went down, but the frequency is a lot more frequent. Now the frequency went up. So that would be, again, these went opposite, so this would be an example of an inverse proportion. It's completely opposite. Okay, so don't get confused. Just think about it. If one goes up, does the other one go down? If yes, it's inverse. If they both go up, then that is a direct proportional relationship. Okay, that is around what you'll see. The last thing that you guys will see on that first part is list the parts of the electromagnetic spectrum, starting with radio waves. So how I like to remember and how I was taught is there's a famous rock star, made up rock star, of course. His name was Weimer. So super weird name, right? But for a rock star, might work, right? And this was just an acronym for the electromagnetic spectrum. Again, go and review this right here. It goes over all of them, but I'll leave this up so you can see. So Weimer, where the first one is gamma having the highest, X-ray being less high. Then we have ultraviolet. Then you've got visible, that's the one that we can see, so our color range from black to blue, green, yellow, red, purple. Then you've got infrared, that's that night vision, where you see heat signatures. M is microwaves, and R is radio. Okay, so this is going from high to low frequency. So the gamma has very high frequency, the radio has a lot less frequency. Okay, here in your practice test, it says you're listing the parts of the electromagnetic wave starting with radio, so you would go the opposite. Radio, micro, infrared, you just go the opposite direction. All right, but that is your short review for all of that first unit stuff that we did for this section. Now let's move on to the stuff that's giving everybody trouble or hard time. It's just a lot different. All right, so we'll go to number 10, sublevels, number of orbitals, electrons max, location on the periodic table. All right, so remember for the sublevel, we have different energy levels. Let's do an example. I can say 3p6. This is the energy level. This is the sublevel. This is the number of electrons total that can fit in there. Okay. For your sublevels, you've got an S, a P, a D, and an F. Okay. Number of orbitals that fit in the S, we know that the S has only 1 and that 2 electrons can fit in there. We know that the P has 3 orbitals and that 6 total can fit in there. D orbital, we know we have 5. Just multiply that 2 times right. 5, that'll be 10. And then F, we know we have 7. 1, 2, 3, 4, 5, 6. Let's just write one here. 7. All right, and that'll be that. Whatever many orbitals, this, you have 1 orbital multiplied by 2, you have 2 electrons. You have 1, 2, 3, multiply that by 2, you have 6 electrons. 1, 2, 3, 4, 5, multiplied by 2, you have 10 electrons. 7, you would have 14 electrons. Okay? Location on the periodic table, you guys are expected to know this, right? Where this is the entire S section. This is the D section. This whole thing is the P section. And really, this 1s2 is that helium element that's right there. That's the only S that's over here. Everything else is going to be in the P section. And then you finally have your 4 Fs in this section. Okay, you guys are expected to know this and memorize it by now because you've worked out enough problems that you should know all of it. Okay, so I'll move on. All right. As far as define each of the following, explain how it relates to electron configurations. Remember, for this, you guys had 3 rules. Rule number 1 is simple. It's the Aufbau principle. Aufbau, you're going to have to know what each one is, but Aufbau is just fill in the first orbital before you fill in the second one. So if I'm putting in electrons in and I have, let's say, 10 electrons to give, I'm not going to start at 2. I have to first fill my first floor, right? It's like building a house. How can you build the second floor if your first floor isn't built? So I'll put my first electron right there. Now for my second, and I'll do half arrows instead of, I could do full arrows, but if I do a half arrow, just know that that's pointing up. This is pointing down. All right, the second rule is my Pauli. The exclusion principle was exactly what I just did, whereas if one points up, the other points down. It's as simple as that. So right now I've got 10 electrons to give. I've given 2. I followed my Aufbau because I filled in my first floor. I followed my Pauli because they're opposite arrows right now, so everything checks out. And then last rule is my Hund's rule. So 2s, I know we'll have that. 2p really has 3 sections. 1, 2. Oh, see, there I made the mistake. I didn't follow my Hund's rule. And Hund's rule is this. You cannot fill, if you have, these are your p orbitals, you cannot fill this one in first, right? It's like if you guys were walking into a room and you saw 2 empty desks. You're not going to want to sit by this guy. You're going to want to sit at your very own desk. If a third student comes in, he's going to want to sit at his very own desk as well. Now the fourth student that comes in, he's kind of messed up. He has nowhere else to sit. So now we have to go in this guy. So that's what it is. You want to fill in your empty spaces first, before you start filling in the places that already have an electron configuration. So between here and here, I want to choose this one. Again, your arrows, anytime you put arrows, the first one is always going to be facing up. After that, you can work on putting them face down. So that's, let me see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this followed all three of the principles. Okay, number 14 does a good job of student mistakes that you'll see. So examine each of the following portions of the orbital diagram, state whether Heinz rule expression or both. I'm just going to go which ones are violating the rules. So you have A, right? A is obviously wrong because you have 1, 2, and this one is full. So two things are happening here, right? And let me go back up. Two things are happening there. Two mistakes, common mistakes. One of those mistakes is, so the person went and put the arrow up, up, and then up, up. This one should not be here. One, it should not be here, and two, if it was here, it shouldn't have been pointing up. It should have been pointing down, and it should have been next to the first one. You always want to go back to the very first one. B, right? You go similar mistakes. You go up, up, next one, then down. We know that that shouldn't be there, and this one is down. So we know that both this is wrong and this is wrong. That should have been facing up, and that middle one should be over here. C, it's kind of the same. You kind of understand it by now. D, you filled out all your orbitals except one. You have to fill out all of them. You can't just leave one blank like this. Like that would never happen. You can't choose to do up, 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 down, then that, right? That doesn't make sense either. Okay, so these are pretty straightforward. And hopefully by now you've gotten them. All right, so now we're on the last page. Now we're closer to being done. Hopefully this is helping you out for what you'll see on the test. All right, so we're going to go to number 16. 16, we're going to do, let's do C, argon, AR. Determine the long electron configuration for each of the following AR. All right, so AR is right there. It's number 18. Okay, I know I can look at this, and this is going to help me. Ideally, you're not even looking at this. I'll do the first one just by looking at it, but ideally, you don't even have to look at this point. So I'll do it in here in the bottom. So AR, all right? So to get to AR, you want to include everything it takes to get there. So AR is right here, so I'm going to include every single thing I have to do to get to AR. So for example, 1s, 1s2, I'm not at AR yet, so I want to include that. Then 2s2, that's something else. I'm not at AR yet because AR is over here. So I'm making my way. Now I skip this whole blank space, 2p1, 2p2, 2p all the way to 2p6. That's full. I can't go any further, so I'm going to include that there. I'm still not where I'm supposed to be. I'm getting closer though. 3s1, 3s2, not there yet. Skip this entire section. Now I'm really close. 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. I finally got to AR, 3p6. So this would be the full electron configuration for AR. Okay, we'll do one more. Let's do nickel. Let's do nickel, sure. Where's nickel? Nickel is right here, element 28. So it'll be, nickel will be right there, 3d8. All right, so you just start again. Go to your very top. 1s2 is complete. Next is 2s2. Next is 2p6. Next is 3s2. 3p6, going directly from that. We're almost there, not quite. Next is 4s2. We're not there yet. And now we're at 3d. We're not going to do 3d10 because we don't go all the way to the right. We're going to do 3d1, 2, 3, 4, 5, 6, 7, 8. And that's where nickel is, so that's exactly where I'll stop. 3d8. And I am done. All right, let's do determine 17, determine noble gas configurations. Remember that the noble gas configurations are shortcuts. There are, so we don't have to write these long electron configurations. It makes our life a lot simpler. So for example, rather than writing 1s2, 2s2, and all of that, I should have just kept it. Right, but rather than writing all of that, remember there are two rules. I'll do this for nickel. There are two rules for noble gas configuration. Go all the way to the right, one up. The reason you want to do that is because that includes everything here. So you don't have to say 1s2, 2s2, 2p6, 3s2, 3p6. That's all included. So when you say that element that's right there, which is, let me look, nickel all the way to the right. Okay, it's argon. Now that I said argon, that's the same as saying all of that, except I don't actually have to say it. The second rule is just to do whatever's left over. Whatever's left over that this element didn't cover is right here, which is 4s2, 3d8. And that's basically it for electron gas configuration, which is just a lot simpler, obviously a lot less time than writing everything together. We'll do one more. Let's do strontium. Let's do SR. SR is all the way over there, SR. So I know that that's 5s2. Let's do my pen. I'll go all the way to the right, one up, 4p6. That's going to be Kr. So I'll just do Kr. Again, this Kr covers everything above this line. I don't have to worry about it. I'm done. All I care is about the excess. So to get to SR, which is right here, the excess is just 5s1, 5s2, and I'm done. Okay? All right. We're almost done here. Let's do the electron dot, or nope, we're going to 18. We're going to draw the orbital diagrams. All right. Now, when I talk about the electron diagrams, I'm talking about this stuff. The 1s, the 2s, the 2p, the 3s, the 3p, the 4s, the 4p, and so on, where s's all have one orbital, p's all have three orbitals, and we'll get to 4s, 4p, we'll get to 3d, that'll have 5. All right, let's do V. Let's do one for vanadium. So vanadium is right here, 23. It's element number 23. I know it's got 23 electrons, so I'm just going to put them following the three rules. So 1, 2, 3, 4, 5, 6, 7. Now I can go back 8, 9, 10, putting them in with the opposite spins. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Oh, sorry, I forgot we were just doing 23. My bad. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21, 22, 23. This is where I would have stopped. Sorry, I went a little overboard. I thought we were doing 30 for some reason. All right. But anyway, this is what I mean. You guys, I'm not going to go through another example because it's pretty straightforward from there on in. All right, guys. Now that brings us to the valence electrons. Your videos cover valence electron. I'm going to give you a shortcut, and that's as much as I'm going to do. If you want more details, please watch the videos because that's going to make everything click. Okay. So, the way valence electrons work is, let's look at this. Okay, so valence electrons are just how many electrons are on the outside. Okay, notice it's not great. Yeah, let me not say that. Notice that I'll just give you a shortcut. Okay, the shortcut really is going to be that all group 1 valence, or all group 1, so all of these on this first up and down group are going to have 1 valence. Group 1 has 1 valence. Group 2, all of these are going to have 2 valence electrons, and these are just the outside orbital electrons. Your video covers it, so I'm not going to cover it here. Group 13, so right here, we skip this entire section. We usually don't care about this section. We'll have 3 valence. Group 14 will have 4. Group 15 will have 5, 16, 6, 17, 7, 18 will have the complete electron 8. So make sure you know that. Again, I'm not going to go over it. Watch the videos. It goes over it in detail. All right, but why do we need to know that? So we need to know that for questions 19 and 20. Let's do 19 first, or actually let's not skip. Let's do draw the electron dot diagram for each of the following. Electron dot diagram is just, let's say we're doing it for boron. Let's draw boron right here. Boron, all we have to do now is figure out where it's sitting. It's in group 13. Group 13 has 3 valence electrons, so I'm just going to make sure to draw 1, 2, 3 dots around it. And that's pretty much it. That's how easy it is. Iodine, find it. It's in group 17. So that's going to have 1, 2, 3, 4, 5, 6, 7. It's that easy. And that's as much as I'll cover from that. Let's go to the next set of questions. Determine the number of valence for each of the following. This is relatively easy. We've just done this. J, A, and Ne. Let's do Ga. Sorry, Ga. Let's find it first. Ga, gallium right there, group 13. So it's going to have 3. And E's right here. It's a noble gas. It's in group number 18. It's going to have 8. The only exception to this 18 in group 18 is helium, because helium only has, look at it, it only has 2 electrons. Helium, and in the first energy shell, you can only fit, in that first energy, you can only fit 1, 2 for the 2 electrons. So this is the only one in group 18 that has 2. Everything else in group 13 is going to have 8 electrons. Helium is an exception. All right, almost done here. Okay, I will also teach you a shortcut here for 23. Let's move to 23. So before I do this, let's talk about the principle behind this, okay? The principle is, we're talking about, first of all, we're talking about electrons. Electrons are negative, okay? If you are, let's pick, I don't know, let's say X is a made-up element. Let's say X has 1, 2, 3 electrons. If X loses these electrons, they go away. Now this, there's 3 of them. Now this -3 is away from X. Now it's, these electrons are over here being all negative, which means this is slightly more positive because it got rid of 3 negative things, right? If you get rid of your negativity and you make it go away, you put it over here by itself, now you become a slightly more positive person. Let's say the opposite happens. Let's say this negative energy is coming in, and now you are gaining this negativity. Well, now you've become negative, so now you'd be -3. That's kind of that principle we're going to apply here. So if you gain, you're negative. If you lose, you're positive because you got rid of negativity. Okay, so let's do for element Mg. And then, sorry, last thing I want to cover is the rule. Okay, so this is a shortcut rule. You want to think of one, let me write it out. Group 1 through 18, right? You can either have 1, 2, 3, 4, 5, 6, 7, or 8 valence electrons. Okay, 8 means you're full, you're complete, so you're happy. So we're not even going to look at 8. Right, if we're looking at 1 through 7, so group 1 will have 1, group 2 will have 2. What's the very middle of this, right? 1, 2, 3, 4, 5, 6, 7. 4 is the very middle of it. Okay, I'll tell you, anything to the right of group 14 is going to gain. Anything to the left is going to lose. So you're going to want to follow this kind of set of rule. Anything in 4 right here can go either way. It can gain, it can lose. It's kind of in between. So let's do number, this one, Mg. All right, so Mg, let's find out. Electron dot structure. Okay, so we figure out the group. Mg is in group 2. It's got 2 valence electron. I'm done with that. Lose or gain. Okay, it's only got 2 to lose. It's on this side. It's to the left of group 14, so we already know that it's going to lose 2 electrons. Lose 2 electrons. And then the last bit is ion formula charge. Well, if you lose your negativity, if it goes away, well, now you don't have those electrons weighing you down. Now you're a happy person by +2, because now these aren't negative, they're away from you. Let's do another one, chlorine. Cl. So first thing, Lewis dot. I know that Cl is in group 17. I know that it's going to have 1, 2, 3, 4, 5, 6, 7. Lose or gain, it's over here, so I know that it's going to gain. How many is it going to gain? Well, it just needs 1 more. It's missing. It's got 1, 2, 3, 4, 5, 6, 7, 8. Remember, to be complete, it needs 8. It's missing 1, so it's going to want to gain 1. And the charge would be, if you're gaining an electron that's negative, well, now you've become a slightly more negative, so now you're going to be Cl -1, because you've gained that extra negativity. All right. This concludes your practice test review. This is pretty much all you'll see on your test. Hopefully you watched this video and took notes, and good luck on your exam tomorrow.